Hello everyone, this is Injaratiu, and today I'm going to talk about a course which is Introduction to Power System for helping students who take exit exam in 2015. So before starting the course, I'm going to talk about the core course comment all specializations. From this, the following courses were selected to evaluate the course Electrical and Computer Engineering competencies. These are Fundamental of Electrical Engineering, Computer Programming, which is Introduction to Computing, Applied Electronics 1, or its Electronic Circuits, Signal and System Analysis, Digital Logic Design, Network Analysis and Synthesis. These are core courses for common to all specializations. And when we come to electrical power engineering specialization, which includes introduction to power system, it's electrical power engineering specialization. The first one is introduction to power system. Introduction to power system. The second one is electrical machines, power electronics and drives, electrical installation, energy conversion and rectification, and power system protection and control. These are the 6 specialized course for electrical power students. So these are interrelated courses. When we study introduction to power system, it relates with energy conversion and electrification, and when we study electrical machine, it relates with power electronics and power system protections, and they are interrelated courses. When we study these courses, we have to interrelate those courses. So when we come to introduction to electrical power system, an electrical power system is a network of electrical components deployed to supply, transfer, and use of electrical energy. The third, for the supply, there is generation. The generation one, and an example of power system is electrical grid that provides power to home and industry within extended area. So the electrical grid can be broadly classified as the generation that supplies the power. Generation. It may be hydropower, solar, wind, thermal, and AC. These are, we can generate electric power from those: hydropower, solar, wind, thermal, and sea. Let's see. The next one is the transmission system that carries the power from the generation center to the load center. Transmission system, which carries a bulk power from generation station to distribution station, which is the link between the distribution station and generation stations, and it goes a long distance by carrying bulk power. The third part of electric grid is a distribution system that feeds the power to the nearby homes and industries. So electric grid, generation station is here, and this is a transmission station, and this one is the consumer side. So small power systems are also found in industry, hospital, commercial buildings and homes. In industry, for example, cigar industry, in hospitals, commercial buildings and homes. So the majority of those systems be used for upon three-phase AC power, so the standard for the large-scale power transmission and distribution across the modern world. Specialized power systems that do not always rely upon the three-phase AC powers are aircraft, electric relay systems, ocean liners, and submerged and automobiles. These are single phase. Single phase. The next one is a power system zone. So power system defined as a network of one or more generating units, loads, and power transmission lines, including associated equipments connected. So a power system have a high level of interconnection and operating over a wide range of voltages. Electrical power engineering is concerned with generation one, the generation, transmission, and distribution, and utilization of electric power, usage of power. So electric supplies can be broadly classified as either DC or AC. DC, AC, overhead and underground. So for a long distance, distance, DC is preferable than AC in terms of economy. So overhead or underground systems, electrical supply systems. In case of a cost, overhead supply is cheapest or cheap than that of underground systems. Look this figure. There is a generation, sub-transmission, transmission, and there is the customer. So every power system has three major components: generation, load, transmission, and distributions. In generation, generation is a source of power that ideally with a specified voltage and frequency. Specified voltage. A voltage and a frequency. In Ethiopian standard frequency is 50 Hz. A load consumes a power ideally with a constant resistive value. In transmission distribution system transmits power ideally as a perfect conductor. So generally power systems has these three common systems, functional zones: generation, transmission, and distribution system. In the transmission system, as we said before, the bulk transfer of power by high voltage links between main load and the center. So the transmission lines are the connecting links between or the generating station and distribution systems. When the distribution system is the transportation of power to the consumer by means of low voltage network, it's a short transportation of power. A distribution system connects all the individual loads in a given area of the transmission line. So a generation system, which is the source of a power, involves the conversion of energy from an electrical form such as thermal, hydraulic, or solar energy to electric energy. This is energy conversion part. Electric power is generated in the range of 11 to 25 kilovolt. The next one is electric power is generated in the range of 11 kV to 25 kV. Beyond this, it can't generate in case of computation problem, which is increased by stepped up transformer to the main transmission voltage or to the main transportation system, 66 to 400 kV or higher than that of these lists. So from flow of generation, transmission, and distribution system, look at this one. There is a generation station and it goes like this: generation, then there is a sub-distribution, then it's home distribution, otherwise it goes to a factory or industries. Look this one. There is a power plant generation, then this is a type of a pole, steel pole, and this is a substation, and this is transformer. A transformer steps up a power pole. There's types of pole, steel pole, and transformer, a pole mounted transformer. Then it is a hole. This is a single line diagram of a power system. Power system generation takes place in a power plant, which may be geographically dispersed or spread. A power plant may house more than one generating units, and it's interconnected. Most of the power plants are classified based on energy sources. Based on energy sources. So when hydrocarbon, it's thermal, coal, gas turbine, and water, it's hydropower, solar energy, nuclear, thermal power, nuclear power, chemical, battery, or other source, wind, it's wind, and tidal is ocean types. So source of power system generators are classified as conventional and unconventional. Conventional energy sources are sources that are used mostly. So conventional energy source, a source of energy that has been widely used for years. These are thermal, nuclear, and hydropower are main conventional sources of energy. These methods of producing electricity often referred to as conventional energy. So they are more traditional and more commonly used source of energy. So hydropower generation involves the storage of hydraulic fluid, water conversion of the hydraulic potentials, energy of the fluid into mechanical kinetic energy, in hydraulic turbine, and conversion of the mechanical energy to electrical energy in electric generation. See, this interrelates with energy conversion and electrifications. So the term hydropower is usually restricted to the generation of shaft power from falling of water. Therefore, energy, either kinetic energy or potential energy, then mechanical energy. So hydropower is usually restricted to generation of shaft power. This uh, potential energy, which is mgh, mass, gravity, and height. It's the height of the dam, and there's kinetic energy half mv square, and the mechanical energy is the sum of the potential energy plus kinetic energy. So the term hydropower is usually restricted to the generation of shaft power. So the power is then used for a direct mechanical purpose. Drives the turbine, or more frequently for generating electricity. Look this one. Hydropower station utilizes the potential energy of water at a high level for generating electrical energy. There is a dam. This height, and this is a penstock, and this is a turbine. Water comes to this penstock and heats this turbine, and the turbine rotates the generating the prime the turbine, and the turbine connects to the generator shaft, and the shaft rotates the generator to generate electric power. We need prime mover, conductor, and magnetic field. So as this setting fulfills, the generator generates electricity. So a water head is created by constructing a dam. The head is the height of the dam across a river or a lake. From the dam, water is led to a water turbine through a penstock. Look, this is Sabayatu dam, and this is the dam. This is water, and this is a dam. So as the water falls through a certain height, its potential energy is converted to kinetic energy. Potential energy is changed to kinetic energy. is converted to kinetic energy, and this kinetic energy is converted to the mechanical energy by allowing the water to flow through the hydraulic turbine. So the turbine drives the alternator which converts mechanical energy into electrical energy. Therefore, hydropower now accounts for about 20% of all electric generation output. Depends on rainfall and the landscape. This is the penstock. The penstock in Sabaito. This penstock is this one. The structure of a power plant. And this is the generator. This is the generator in Sabaito. Look this one. And this is the turbine. This one. This turbine is practically like this. Then the wiki gates, this one. This wiki gate is this one, this. And there is a turbine blade. The next one is thermal power station. A generation station which converts heat energy of coal combustion into electrical energy is known as steam or thermal power stations. So in thermal electric power plant, electric energy is produced by burning of coal, oil, or natural gas. So the heat related by the combination of coal produces steam in a boiler at a high pressure and temperature, which when passed through a steam turbine gives off some of its internal energy as mechanical energy and is condensed in a condenser to be fed into the boiler again. So the steam turbine drives the alternator which converts mechanical energy of the turbine into electrical energy. This type of power station is suitable where coal and water are available in abundance and a large amount of electric power to be generated. So this is fuel. There is a burning fuel, then heat water to make a steam. This steam heats the steam turbine. Turbine turns the generator, then the generator generates electric power. The next power station is nuclear power station. A generating station in which nuclear energy is converted into electrical energy is known as a nuclear power station. A nuclear power station heavy elements such as uranium or thorium are subjected to nuclear fission, the breakup of nuclei of heavy atom into two nearly equal parts, which release a huge amount of energy is known as nuclear fission in a special apparatus known as reactor. So the heat energy thus released is utilized in raising steam at a high temperature and pressure. So the steam runs the steam turbine, which converts steam energy into mechanical energy. So in the power station name is given by the type of prime mover. In hydropower, there is water. The prime mover is water. In nuclear and thermal, there is steam runs. This is the steam turbine. The steam. So the turbine drives alternators, which converts mechanical energy into electrical energy. So the most important feature of a nuclear power station is that huge amount of electrical energy can be produced from a relatively small amount of nuclear fuel as composed to as a conventional type of power. So it has been found that complete fission of 1 kg of uranium can produce as much energy as can be produced by the burning of 4,500 tons of high-grade coal. Look the comparison. The other type of energy source is solar energy, wind energy, tidal wave energy, biogas energy, and geothermal energy. Solar energy is the main consists of all the available energy sources, which relates to this energy conversion into electrification. The major source of renewable energy is the sun, which converted into different forms: solar radiation, wind, wave, and sea. Solar energy refers to the direct use of energy contained in sunlight in the form of heat and light. The heat energy used in a solar heat device like solar cooker, solar water heater, solar furnace, etc. The light energy is used in a solar cells. The next one is wind energy. All moving objects contain kinetic energy. Kinetic energy. The kinetic energy of the wind can be changed into other form of energy, either mechanical or electrical energy through wind turbine generators. Turbine generators. So how electricity is generated by wind turbine? Wind blows over the angled blade and results in a turning force. Turning force. This is a blade, and this is gearbox to increase the speed, and this is a generator. And this is a tower. This is a hub which connects this blade and this blade. The force will turn the shaft, gearbox, and generator, which are all connectors. The gearbox increases the rotation speed, enabling the generator to produce electricity. A single windmill produces only a small amount of electricity. So a large number of windmills in a large area are coupled together to produce more electricity in wind energy. That's why in Adama wind farm have more wind blades. The next one is geothermal. Geothermal energy originates from the inner core of the Earth, and it's evident on the Earth's surface in the form of volcanoes, geysers, and hot springs. The deeper region of the Earth's crust is very hot. This heat melts the rock and forms magma. The magma moves up and collects below at some place called hot spots. So the underground water in contact with hot spot gets heated into a steam at a high pressure. Steam at pressure. So by drilling hole into the hot spots, the steam coming out can be used to rotate a turbine of generator to produce electricity. So it is known that the largest geothermal resource in Africa is available in Ethiopia. This one of the discharging wall at Alatolangan. The next one is tidal. The periodic rise and fall of sea level due to gravitational attraction of the moon causes tide. A dam bridge is constructed at a narrow opening between the land and the sea. The movement of water during high tide and low tide can be used to rotate the turbine of generators to produce electricity. The next one is biogas. It's a name applied to gaseous product released from anaerobic decomposition of different bio-wastes. In this process, organic wastes are anaerobic fermented by microorganisms. The gas thus produced contains about 60% methane and 40% carbon dioxide. Biogas can be produced from cow dung, leaf litter mixture, animal extra, particularly dairy cattle, pigs, and chips. The next one is power transmissions. Transmission is a network connecting generating plant to consumption points, interconnecting power poles, high voltage AC, high voltage DC, and high voltage transmission offers lower transmission loss disadvantage and lower line voltage drops, high transmission capacity, lower capacity, and operating costs. Transmission of electric power by high voltage DC system is superior to that high voltage system in many respects. The first one is it requires only two conductors for transmission as compared to that of three in AC. No inductance, capacitance, and phase displacement problems in DC transmission. There is no skin effect in a DC system, therefore entire cross-section of the line conductor is utilized or used. A DC line has less corona loss and reduced interface with communication circuits. For the same working voltage, the potential stress in insulation is less in case of DC system than that in AC system. Therefore, a DC line requires less insulations. So the high voltage DC transmission is free from the dielectric losses, particularly in case of cables. In DC transmission, there are no stability problem and synchronization of difficulties. The only disadvantage, electric power cannot be generated at high DC voltage due to commutation problems. The DC voltage can be stepped up for transmission of power at a high voltage, so the DC switches and circuits break have their own limitations. AC transmission nowadays, electric energy is almost exclusively generated, transmitted, and distributed in the form of AC. Advantage: the power can be generated at a high voltage. Maintenance of AC substation is easy and cheaper. The AC voltage can be applied, stepped up or stepped down by transformer using as and efficiency. This permits to transmit power at a high voltage and distribution is at safe potential. Transmission disadvantage. Thank you for watching. We'll continue next. Thank you. Don't forget to share, subscribe, and comments.